Hey kiddos! Today we are going to be talking about reflection. So this is the next transformation. So what is a reflection? It is a transformation that uses a line like a mirror to reflect a figure. The mirror line is called the line of reflection. A reflection in a line M maps every point P in the plane to a point P prime. For each point, one of the following properties is true. If P is not on line M, then line M is the perpendicular bisector of segment P to P prime. If P is on line M, then P is going to be congruent to P prime. So basically, these are the pictures, the visualization of those two situations. So if point P is not on the actual line, when we reflect over line M, then that would mean that segment would end up being a perpendicular bisector, meaning that it has perpendicular has a 90 degree, and bisector that those two pieces would be cut into, that segment would be cut into two congruent pieces. If point P, though, is on the line, then when you reflect over that line, it's essentially the exact same point. So those 2 points, P and then P prime, would be the same. All right. So there are some coordinate rules for reflections, and we'll create a foldable where you guys will have the opportunity to actually write this information down, because they're basically shortcuts to get the answers. Okay, so if you have a point AB and it's reflected of the x-axis, then its image, because remember the first one is called a pre-image, and when you move it, it is then called an image. Then the image would be at points where you have A and then negative B. If you have a point that's reflected of the y-axis, then its image would be at negative A, positive B. If you have a point that's reflected in the line of y equals x, then its image is point BA. And lastly, if you have a point reflected in the line of y equals a negative x, then its image is negative b, negative a. So like I said, these are just shortcuts, and you guys don't have to memorize them. I'll let you guys write them down in our foldable that we'll create at the end of all the transformations. Glide reflection is a transformation involving a translation followed by a reflection. So remember, we've already talked about translation. Translation is basically the sliding of something. So you're sliding something either right, left, up, down. Okay? So after you do a translation, then you would do a reflection, and that's called a glide reflection. So, it's a transformation involving a translation followed by a reflection in which every point P is mapped to a point P double prime by the following steps. First, you would do the translation, okay, which would go from P to P prime. Then you would reflect it, and in this case, you would reflect it, and line K is what we're reflecting over, okay, parallel to the direction of the translation. So if the translation was in this direction, then we're reflecting in across from it in that direction. So it would move from here to there. And basically, reflection is you want it to be equal distance from the line of reflection. So notice that's why here Q is closest to line K, because on the other side it is closest to line K. So they're going to be equal distance from the line that they're reflecting over when we do reflections. Line symmetry is when a figure can be mapped onto itself by reflection in a line. So the line of reflection is a line of symmetry. A figure can actually have more than one line of symmetry. So basically what we're saying is so in this first figure here, imagine I only have this vertical line here. If I were to draw that vertical line, when I fold this in half on top of each other, the sides match up. So notice I can do that in this direction, the vertical one. And then you can also do it the horizontal version because, again, if I were to actually fold it, those two halves would line up one right on top of the other. Okay, so notice if I were to draw a line like this, those two halves, if I were to fold them, would not line up, would not match up one on top of the other. So that's why that's not a line of symmetry there. For this next figure we have here, notice it has a lot of different options where no matter where I draw this line of symmetry, if I fold it along that line of symmetry, the two halves would end up being one on top of the other. Whereas this one has exactly only one. So there's absolutely no other place that I could possibly draw a line of symmetry. So if I draw one there, clearly that's obvious that those two halves wouldn't match up. If I try to draw one at an angle here, clearly, again, those two sides folded in half wouldn't match up either. So same concept actually applies with a real life figure. So this is how it's applicable in the real world. Real figures do have lines of symmetry, which you can see in this butterfly. All right, so in this first example, we're going to be reflecting in horizontal and vertical lines. So notice I went ahead and graphed triangle ABC with these three vertices of A being at 1, 3, B being at 5, 2, and C being at 2, 1. So make sure that you go ahead and probably pause and get that done. And its image after the reflection described. So we're going to graph, so this is the pre-image. Now we're going to graph the image, which we're going to reflect over the line, which is labeled as line N at x equals 3. Now, x equals 3 automatically tells me that it is a vertical line, okay, at 1, 2, 3. So notice I already drew it. It's the blue line here. And we are reflecting over this line. So to draw the new points, remember it's going to be the same distance from the original one. So for example, point B here is 2 points away from it on the right side. So therefore point B would be 2 points away from it on the left side. So that would be my B prime. A is 2 points away from the left of it. So therefore it would be reflected on the other side. So it would be 2 points to the right of it, and that would be A prime. And then C is 1 point away or 1 unit away from the left of it. So therefore it would be 1 unit away to the right of it. And that would be C prime. So this would be our new picture. All right, and remember that blue line was line N, which was x equals 3. Now, the next problem, we're going to, again, reflect this pre-image over the line M, which is at y equals 1. Now, y equals 1 is a horizontal line. So it's a horizontal line that goes through where y is 1. So that's y equals 1. And we're going to reflect over that line. Remember, it has to be equal distance from one side of the line to the other. So A, if I'm looking at A first, is 2 units from the line of symmetry, or line of reflection. So it's going to have to be 2 units away on the other side of it. Okay, B, I can see is only 1 unit away, so therefore it would be also 1 unit away in the other side of it. That's B prime. And then C is actually very unique because C is actually on the line. So remember what we talked about. If a point is on a line of reflection, then the prime would be the exact same point. Those points would be the same. So that would be our new image reflected over y equals 1. All right, so for the next example, we have the vertices of triangle JKL, which are 1, 3, 4, 4, and 3, 1. So notice I've already have it labeled, which you need to go ahead and plot and label. We're going to graph it, and then we're going to create its image. So remember, this is the pre-image, it's the original one. And we're going to create its image after reflecting it over the x-axis. Okay, so I've already labeled my x-axis, just in case you don't remember which one it is. It's the one that goes left to right. And we're going to reflect this over that line of reflection. So remember, we want them to be equal distance from the line of reflection. It's kind of the best way to do it. So L is 1 unit away. So L prime would be 1 unit away. K is 1, 2, 3, 4 units away. So K prime would be 4 units away. And the last point, J, is 1, 2, 3 units away from the line of reflection. So it's going to be 3 units away, the opposite side. So this is what our new triangle would look like. That is our image, okay, when we reflect the pre-image over the x-axis. Now, to write its coordinates, you can also use the shortcuts that I told you guys about, which is what I wanted to show you right now. So let's say I didn't have you guys even have to graph it. Because obviously if you graphed it, you can easily look at the values now and write them down. But let's say you didn't have to do this part, right? So, poof, it's gone, right? How could you still then determine what would be the coordinates of this triangle? So because it's reflected over the x-axis, I have a shortcut for it. So whenever we have a point that's given to us and we say it's reflected over the x-axis, then we know that the new point, so the image points, would then be changed like so. So notice the only change is that the y value basically becomes negative, or the opposite. So if it was positive, it becomes negative. If it's positive, it becomes negative. So the x value, notice, does not change at all. So when I write my answers here, you'd have 1, -3. K prime would be 4, -4. And then the last one, x stays the same. The y value becomes the opposite, -1. So those would be our new points. And obviously here we can check it ourselves. We see that J prime is at 1, -3, K prime is at 4, -4, and L prime is at 3, -1. So you can see that this shortcut does actually work. Yay. Alright, so for this next problem, we are going to be now reflecting that very same triangle, JKL, so make sure you regraph it. And this time we're going to reflect it across the y-axis. So notice I went ahead and labeled the y-axis, and that's what we're going to reflect over. Remember, this is basically a mirror image is what we're creating. So it has to be the same distance from the y-axis on the right side as it is going to be then on the left side of the y-axis, since that's our line of reflection. So J is 1 unit away on the right, so it's going to be 1 unit away on the left for J prime. L is 3 units away, so therefore L prime would be also 3 units away in the left side. And then K is 4 units away, so therefore K prime would also be 4 units away on the left side. So that would be what the graph would look like if I were doing a reflection over the y-axis. Then to write my new points, remember, yes, I know technically I graphed them so you can easily write them, but I want you to look at the shortcut and what the shortcut says to do. So for the shortcut of reflecting across the y-axis, so notice it does matter, pay attention to that. The shortcut states that we would make the x value the opposite, and we would keep the y value the same. Okay? So, when I rewrite my points then, I'm going to only change the x value to the opposite, keep the y value the same. So, J prime becomes -1, 3, K prime becomes -4, 4, and L prime becomes -3, 1. you can easily check your work here by checking that the graph that we did matches the points that we wrote by using the shortcut. So for the next situation, we are again graphing our original triangle JKL, so that didn't change, 1 3 4 4 3 1. Okay, and that's our pre-image, and we're going to create the image after we reflect it over the line y equals x. So notice I went ahead and drew the line y equals x, which is a parent graph. So this is what it looks like. Notice point K happens to be actually on our line of reflection, which hopefully we remember then what that means about where would K prime be. So notice this time it's a little bit more difficult to determine how far away or how many units away J and L are from the line. So you can always think of like rise over run. So from the line of reflection, J is to the left one, right one, or sorry, left one, up one, or I could go in the other direction, right one, down one. So I would follow the exact same thing going the opposite direction to find J, which would be from here. So from the line, I would go then instead down one, right one. So, well, coincidentally, it becomes exactly where L is. So that now becomes J prime. And L is in the same situation as the other one. So from here we go down one, right one to get to L. So then here I would do the opposite. We would go up one, left one, and L would end up, coincidentally, where J is. That actually becomes L prime. We should hopefully recall that because K is on the line of reflection, then therefore K prime would be the exact same spot. So that's what the new triangle would be reflected over y equals x. And to write the coordinates of that point, so let's say you just totally didn't get this part right here. Don't panic because you have a shortcut because it's a line of y equals x. So therefore, then, we actually can use this shortcut to figure out what the final answer is, okay? So all you have to do here, if you notice, the shortcut is switch the order of the x value and the y value. So you don't change the numbers, you just switch their order. That's pretty easy enough. So J prime will become 3, 1. K prime would be, well, what do you know? The exact same point, 4, 4. And L prime would become 1, 3. Okay, so that is using the shortcut whenever we're reflecting over a line of y equals x. All right, so our final example here, again, we have our original, our pre-image, JKL, and we're going to create our image after reflecting it over the line of y equals negative x. So here's y equals negative x, already drawn for you. So I'm actually going to show you how to use the shortcut to help figure out what the picture would look like. Okay, now the shortcut, whenever we are reflecting over a line of symmetry that is y equals negative x, states that we have to do two things. We will switch the order and we will make it the opposite. Okay, so we're going to switch the order of x and y and we would make them the opposite. So if the numbers are positive, they become negative. If the numbers originally are negative, then they become positive. So my new J prime would be at negative 3, negative 1. So I switched it and made it the opposite. K prime would be, if I switch it, coincidentally it's the same, but it does become negative 4, negative 4. And then L prime, switch it and make it the opposite. So it would be negative 1, negative 3. And then from here, it makes my life a lot easier to plot the points. That's where J prime is. That's where K prime would be. And that is where L prime would be. So you can kind of see how to go about finding it here. So let's say it's a little bit more complicated to go at diagonal. I mean, if I were to draw a diagonal, I know I went through 2 units, so I know it'd be 2 units away diagonally. Same thing here. I'd be going through 1, 2, 3, 4 units diagonally, so I'd be going through 1, 2, 3, 4 units diagonally. Here I went through 2 units diagonally, which means I would continue that 2 units diagonally. Or you could just do kind of like a rise over run, down 2, left 2, so down 2, left 2. Same concept here, down to left 2, because I always want to get to the line first, down to left 2 to get to the new one. So, yay, but these shortcuts most definitely help. Alright, so for this next example, we're actually going to do a glide reflection. Remember, a glide reflection means that we do a translation first. So we do the translation first, and then wherever we moved it to, then you would move that image by reflecting it. Okay, so our translation is given to us here. It's x minus 12 comma y. Notice the y doesn't have anything, so I rewrote it to say y plus 0. So the x means we move left or right, so it's minus 12, so that means I'm going to be moving. Hopefully you graph this. If you need to pause, go for it and graph. So I'm moving each one of these points to the left 12, and because my y is plus 0, that means it doesn't move up or down, okay? So literally all I have to do is move this 12 units to the left. So when I make that translation and I move each point to the left 12 units, I end up with this new a prime, b prime, and c prime, which a prime is at negative 9, 2, b prime is at negative 6, 3, and c prime is at negative 5, 1. Now we're going to reflect across the x-axis. So notice I went ahead and labeled the x-axis for you. So we're reflecting this image across that one to create our brand new image. So our a like double prime, b double prime, and find c double prime, okay? Remember, you can also actually use the shortcut rules, but remember, you're going to use a shortcut rule for the x-axis, so make sure you write down the right one when you do this, and I'm going to let you guys do that part on your own. And the last example here is about determining the number of lines of symmetry for a figure. So it's easier sometimes if you use a ruler to draw the lines. Make them look as straight as possible, please. So for example here, if I were looking at the rectangle, I know I can draw a line of symmetry here, because it would be, well, I know it's kind of poorly drawn because it's not like right dead in the center of it, but you guys generally get the idea that if I were to fold that rectangle on this line, this part would be right on top of this part. I can also draw line of symmetry this direction. So again, if I fold it along this line now, this section would be folded on top of that section. I don't think I can draw any other ones because diagonally, nope, those two halves wouldn't fold right perfect on top of each other. If you don't believe me, grab the sheet of paper that you have right now and fold it along a diagonal and see if those two halves would match up. Not going to happen. So therefore, this one only has 2 lines of symmetry. You guys now are going to do these last 2 on your own. So make sure you guys keep that concept in mind that I should be able to fold it right on half. One half right on top of the other. So, awesome sauce. Adios.